Does somebody else have their mouse? I'm not touching it at all.
Are you logged in as yourself?
Yeah.
I would just go ahead and unplug it and
It's like someone else has them now.
I wish someone did Bluetooth. That would be kind of fun.
I've done that before. I just
figure out which quarter it is. Unplug it and start over.
Is it when he's scoring with me?
So it appears this one is still not working.
God.
It looks like a second computer up to the on the front there. Should be freed up soon. Or at least the Windows part is up. It's just the password's not working, right?
Yeah.
No. Well, that's a start. At least it's on.
So we did not turn on before at all?
Yeah.
No.
Slow
It's getting
progress.
closer.
So when? Oh, there it is. Now I'm gonna go crazy. It's not doing it.
You need to find out a couple things from you.
So we just need like a blank one up. We're gonna like follow you or just listen.
Yeah. You just need to open up a new conceptual environment for today and conceptual mass, and we'll work in there.
That's why I
All right. You almost got everybody.
Looks like we have another computer running.
Yeah, whatever number that is, number 2 maybe.
Brian, you can move up to number 2.
Right.
Yeah, but I was working at you. It's not, I think we want to go.
I mean, it'd be amazing if everything just worked at one time.
Welcome back, Rusty. Welcome back. Thank you. Thank you.
Oh, the computers that were not working.
All right. So, what kind of issues are we having? What kind of issue are you having?
I need some therapy.
I think I've heard maybe three issues so far, and I'll go over them, and then maybe you guys can add on to them, or maybe you say you've already resolved them. Number 1 is some people are having behavioral issues with their spline, meaning that you have all of your points and it wants to connect them in different ways than you're expecting them to. Anyone having that problem?
Mine's lofting the different splines is not in order that I'm clicking them. Like the splines, or it will spline between the points correctly, but then when I go to connect the lines together, I think I came to like the 8th one I made. If I added that one, it would just completely change the order, even if I clicked them in the correct order.
Okay, so you've got a series of section curves.
Yeah.
And
then when it would connect, like the first 7 I made, it was doing it correctly, and it was doing them in order, and then I made another one, and then whenever I tried to add that one, it completely changed the order of the connections.
Okay. What about accuracy of placing your section curve? Once you've made your curve, so you should have a curve type that you've experimented with, and you've got a series of points and maybe some parameters. And if you bring that in to the other environment, and like we did in class, we placed it attached to another point that we can move. Some of you were talking about, is there a way to make that a little more accurate as far as how to place that curve? Anyone having issues with accuracy?
Yeah, placing issues with where the curves were placed in
Relationship to the point?
Yeah.
Okay.
It actually, I also had a problem with, I can't snap to the horizontal plane. And for some reason, it gives me like sort of X and Y planes. Whenever you use the type into the.
You don't, so you can't get the horizontal on the point?
It still worked, but
Okay.
I just wasn't sure how close.
Yeah, it might be, how did you initially make your curve in the other file? Did you do it in elevation view?
No, No,
Okay, so it was already related to some level 1 plane. Okay. And I'm trying to think of what the other issue was. I think I've forgotten my third one.
I had trouble associating the points with my curve. Well, I tried, okay, the curve wouldn't show up.
And the curves won't show up.
Yeah.
Okay. Well, what I'm going to do here is show a quick example of where I think we're going with this project. I think that looking at everyone's model, you can make every part of this model with one curve. And basically, you're going to come up with different curve types that can be placed on different reference planes or reference points, within the other environment that locates it in space that can be, these curves can be lofted together. Anybody start making too many curves in their first attempt? It looked like some of you already had a file that looked like this, and then you were actually building your other curve within the same file. You can do that, that'd probably be a method, but you're going to end up with a lot of different points, a lot of curves, and a lot of parameters probably. What I'm looking at is, I could probably look at, well, I have looked at all of my curves, and I've decided that I can probably make every shape on this model with 10 points on a curve. You might have a different number depending on how tight your curves are and however many, however long your bridge might be. But my worst case condition was this particular form, and probably this one. But each one, I kind of figured out that I could at least get 10 points to make up one edge, and then another 10 points to make up the other edge. And basically all I'm doing is, in the X, Y, and Z, based off of this lower right-hand corner as my 0, 0, 0. So that would be, if you're looking up on the screen, this point right there is basically my reference for starting each of these curves. And I'm just doing how far is this point in the Y, in the X, and the Z from this origin point. And I could do that with each and every curve. If I only have 10 points, it's a matter of just changing the values of all of these different numbers. And then that's the construction of just making the curve itself. Then we can bring that into another environment, and then it's all about how to place that curve, in some kind of fashion with a reference point that we can, move up and down in space eventually. So that we can have basically a completely programmable bridge or tower, because one curve is going to be able to adjust and manipulate, and you can make adjustments fairly easily. Some of you have asked about if there's other ways to make surfaces in Revit besides points and these splines and so forth, and the answer is yes. You can use sweeps, extrusions, blends, all these other tools that you're probably more accustomed to in Rhino, but not in this environment. That would be in what's called the generic model family environment, and basically every other family environment has those set of tools. But with the massing tools, it's all about reference planes and points, and reference points associated with lines and splines to make the surfaces. The reason for that is we're making masses, and in Revit, these aren't really going to be our final objects. A mass in Revit is kind of a hidden element. It's something that's seen as an underlay. When you bring it into a project environment, in fact, most of the time your visibility graphics by default has masses turned off, because masses are used as a form generator to apply real building components to it. And so everything that we're doing here is kind of a setup for these additional components that are going to get applied to this surface. And what happens is when you start to manipulate your surface and your mass, your real building elements that have been assigned to it will also update and translate as well to all the different changes that you make. So, don't get too hung up on the fact that we don't have all the different sweeps and extrusions and all that kind of stuff. We'll get into family environments that allow us to do that. It's just those family environments can't be used as an underlay. It's just the way that Revit's set up, there's all these different categories and different templates that you always have to work within. And so for conceptual design, this is the environment. And maybe one day they'll start to bring in the sweeps and the extrusions and things like that, which would help a lot. But for now, the method is always going to deal with points, and we're going to be dealing with splines, indoor lines, or basically any of these draw commands that you can use up in this left-hand corner. So one of the things to solve the issue where everybody has, not everyone, but some of you have had some issues where your spline might want to, you've placed all of your points, you've got all the different parameters happening, and what you don't see here is I've turned off my dimensions in my visibility graphics so that I can actually see what I'm doing from time to time. So, remember to hit a VG, and this allows you to look at model categories and annotation categories. Anything that is a dimension or a text or any kind of label is an annotation. And so it gives you the ability to turn off your dimensions and things like that too. So if your drawing really starts to get kind of heavy and you just want to see the final product at the end, you can just turn off the dimensions in your visibility graphics. The other thing is down at the bottom, I think by default, this is set to be something like, maybe it's 16th is probably the default. If you happen to have a lot of dimensions and these numbers are really big, you just change your scale down at the bottom to something, like quarter scale. You can see how the text and everything that was associated with the annotation, scales down. This is still shown at full scale. It's just the annotations have scaled to show up as they would if you were to print at quarter scale. That's really all that scale is saying. But what that does is it allows you from time to time, when you start to really get a lot of different dimension strings and everything associated with your family, sometimes you might just want to bump up the scale so that you can actually read and still see what's going on. So what I'm going to do is, let's close out of what I'm showing you here. And if everyone can open a new conceptual mass, I'm just going to go over a real quick process of where I would probably start, and then maybe you guys can share a little bit of your methods of what, whether you've done it in a similar manner or if you've got another strategy that you're looking at. The first thing to solve is the idea of where's our origin point going to be. So I'm looking at my floor plan, and I'm associating it with my analog model. And I want everything to be associated with my lower right-hand corner of my model, and I'm just picking that. You guys might have to pick a different one, but essentially I want everything to grow in the Y and the X in this quadrant up on the sort of the northwest quadrant of when looking at a floor plan. You might want it to grow in another way or whatever, but basically the point is you want to be consistent. You want everything to be growing in one direction. And it's best if you can pick a corner on your model, because then your X and your Y's will always be associated with one of these planes. If you kind of split, pick like a midpoint of your model, then you get into, your X having to go to the left and then your X going to the right. Essentially, when you place a dimension on a point, it cannot go negative. I wish it could, because that would allow you so much more flexibility, but it only goes to 0 and above. And so basically what that means is you can't ever cross this line once you've started to establish parameters to that dimension. You can only grow in that one direction. So just keep that in mind. If you've got points kind of going back and forth, it's okay, but you just have to realize that you're always going to be stuck with that point being manipulated only in that quadrant. So just kind of think about that as you start to set things up. But what I'm going to do, because I said I could do everything in 10 points, I'm not going to go over every 10 point and how you might do this. I did it in my lunch hour. It would take us our whole class right now. But I want to show you that if you just, so I know everything's going to be in this quadrant. Before I even start, I know I'm going to have 10 points. I'm just going to go ahead and place 10 points throughout this quadrant. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to select them all and turn on my reference plane. Now, before I start manipulating where all of these points are going to end up in space, I'm going to go ahead and select them all and create my spline through points. By doing this, I've already established the order in which that spline is always going to travel, and I won't ever have that spline act in a random way because it, basically Revit won't understand, at some point Revit doesn't understand how to connect all of the points if your curve gets too complicated. And it just has to do with the algorithms that are programmed into the spline tool that basically it has some calculation where it's trying to take the average between 2 points and finding the closest and the average mean, and that's how it's deciding how to connect all the points. And if those numbers just in the computer get kind of manipulated in an obscure way, that's when you get into the behavioral issues. So by doing this, we end up with all of our splines will always act the way that we want it to. It'll act in the order. So once I've done all that, I'm going to select all these points again, and I'm going to turn off the show normal so that I get all my X, Y, and Z planes on each of those points. Now, the next thing I would do is, well, you can do either two things. You could go into the family types and start setting up all your parameters. You know you're going to have an X, Y, and Z for each point. So yes, this is going to take a little bit of time, and I'm not going to go through every point right now because I've got the file that I can show you. But obviously for what we've already done in class is you set up your X, Y, and Z for each of those points. And then you can go ahead and start doing each dimension. And what I'm going to do is just load up my other file so that we don't spend a lot of time here. And you guys can kind of just look up above. So what I did is I set up and you could do it in I named these basically X1 through 10, Y1 through 10, and Z1 through 10. And of course, you could also just say 0.1 X, 0.1 Y, do all that stuff, whatever you want to do. But once I establish that, I can then just start making all of my curves by, and if you have a, let's see what I have here, my dividers. And then you might pull out a set of dividers or your ruler or your scale. And I've established that this is going to be at 16th scale. And you can essentially say, okay, well, for the first point, I've marked it on my form. I'm going to go ahead and say from this 0, 0, 0 point, how far over is it at 16th scale? And that's the number I'm going to add in or enter into my X1. Then I might I could do my X, Y, and Z, but I might just do all the X's of the point. So I go to point 2, and you're going to follow it all the way around. And I keep going back to this corner point and making my reference of how far this point is from that corner in the X direction at 16th scale, and then do the same thing in the Y, and then the same thing in the Z. And that will program one, basically one curve type, and then I would just go back. Once you get that set, or you enter in a couple of these values, I would hit apply and OK, and hit save, because once you got that dialog box open, you can't hit save. So every now and then you might want to close out of the dialog box and go ahead and save your work. But then once I've established type 1, I might go to type 2 and start a new family type, and then it's just a matter of doing the same exercise. I could do that for every single curve, and all I'm doing is programming this one curve to act like every single curve that I have on my model. And then this way, when we actually bring it into the new environment, It's just a matter of, selecting that curve and placing it on the reference point.
So you just use the one curve, but then you'd still like measure all the other curves, and you just change.
Yeah, I'd use the same curve, so I got the same parameters, but, when I'm on point number 5 of this curve, my x and my y is definitely a lot different than, on point 5 over here. And so basically that's all that's happening is, how far is that one point occurring? And so what you really have to do is, since it's going to be one curve, you really need to establish a worst case condition and say, well, how many points do I need to make that worst case condition? So for instance, on these very simple curves, yes, I could probably do them with less points, but I still need to use the 10 points to, so that I'm still using the same curve.
Another question.
Yeah.
On mine, I only did 3 curves, like the 3 curves, but the edge of the curve was the curve itself, and then I guess the harder part would be to put it into a different file and then just rotate
How it's
points.
working. So you did like section curves.
Yeah.
Okay. Yeah, and this is one method, and then I want to talk about some of these other methods that I've seen some of you doing. That you can do that as well. I don't really think. I think if you can do your edge curves, you will have less curves to do and less issues with trying to place everything. Because if you're doing the section curves, you gotta then not only figure out all the different ways it's going to bend, but then you also have to figure out exactly where that reference point is going to be in the next model, kind of marching down. So you could do that, but I think if you can try to do it this way, I think it might save a lot more time. So I saved my original starting point. So you can see this was how I started off. I just had everything up in a line, and that's where I established all of my dimensions. And then from there, I have my type 1 curve, and then my type 2. And then from that, once you're done, let me show you a method of how we can place this into the next environment so that we ensure, again, that we're using the same reference point at the 0, 0, 0, which will help you place your initial curves to really replicate what you've done in an analog model. So what I'm going to do is keep this open, and then I'm going to go into user interface and start a new conceptual mass. And I'm going to place a point, and I'm just going to place it up here in the space. Doesn't matter where at the moment. And maybe you guys can all place a point too in your own conceptual mass, because I'm going to show you some new tools that might help you work in this environment. So once I've got this point, I'm going to turn on all of my different reference planes that are associated with it. But in order to get this to be precisely at 0, 0, 0, this little crosshairs, I'm going to use what's called under the modify. You have all of your transform tools up here, which are your align, your moves, your offsets, mirrors, copy, and trim and extends, and scale. These are all your ways of transforming any kind of shape that you have or line. But one thing that you'll use a lot is called the align tool. The align tool is actually made for, well, what it says, to align one element to another, but it's also made to lock and set up constraints later on when we get into that. So we're going to be using this tool often, so you probably want to just kind of figure out its methods of how you actually would use it. What it's asking you to do, and you can look at the lower left corner of any tool that you pick, it always is showing you what it's asking you to do. So it's basically saying to select whatever you want the main object to be that you're eventually going to align this point to. So first I'm going to pick one of these planes, and then I'm going to pick the parallel plane of the point. And then I'm going to do the other one and this one, and that ensures that I'm now at 0, 0, 0. And by default, this point it has an offset at 0, so I know I'm right at that intersection. I'm gonna, since I have my other curve worked out, and you might not have a curve to bring in, so you may have to follow along a little bit here on the screen. I'm gonna load this into the project, and in order to place this curve type 1, so that it's, remember, because in the curve type 1 or the curve type 2 family, I had established everything off of an origin point as well. Whenever you're placing any kind of family, you're placing it always by its origin point, which is this 0, 0, 0 in that file. So if I place it at this 0, 0, 0, it'll be exactly in the same position that it was on the other file. So what I want to do is place it on a work plane. So I need to pick place on work plane. And then my placement plane, I still need to pick this point or this horizontal surface. And I'm going to left click. And when I left click, it's now asking me where to place it. Well, if I hover over 0, 0, 0, you should get both of your crosshairs to highlight. That means you're snapping right to the 0, 0 plane. And I'm going to hit the left click. And now I have that curve exactly in the same quadrant. I'm going to take this point and I'm going to give it a name. I'll call this, this is curve type 1. So that I know that this point is always going to be associated with this particular curve that I placed. Next thing I'm going to do is I'm going to place another point so that I can place my type 2 curve. But before I do that, because I want this point to also be at 0, 0, 0, you'll often get an error that says, hey, did you know you placed a point on top of, you've probably seen this. You have 2 points in identical locations. I always tell Revit, so what? I know I put those 2 points there, but it just gives you a warning once in a while that you have duplicate, it's thinking you have duplicate objects. And sometimes if you happen to place too many things on top of one another, and you don't need them, it's just giving you that warning. I ignore that warning, but before I do that, so I have the ability to select this in an easy way. I'm going to take this point, and if you look at the bottom of every view window, you have these little eyeglasses. The eyeglasses are your temporary hides and isolate commands. Anything that you select, you can temporarily hide in the view. And this gives you the ability to work, especially when you start getting a lot of things on top of one another in 3D, or even in 2D sometimes. You need to hide some things to, isolate what you're working on. And you don't want to do it in a permanent way, because sometimes you can right-click and you can say, this doesn't actually give you the option here. So in this environment, that option's not there, but in the project environment, sometimes you can right-click and it will say you can hide something in the view. And once you do that, it's kind of hidden permanently, and you have to always come back and find it and unhide it from time to time. If you do a temporary hide, so I'm going to click on the eyeglasses and I'm going to say hide element, it goes away. And once it goes away, you get this blue box that goes around your screen. That's telling you up in the left corner that, hey, by the way, just to remind you, you've hidden a bunch of stuff in this view that you're not really seeing. At any moment, you can come back to the eyeglasses and say, reset, temporary, hide, and isolate, and it brings everything back. The other thing is if you save your file and you exit, and then you open your file back again, all of your temporary objects that were hidden are revealed again. So that's why it's temporary. It's not obviously going to be permanent once you save it. So again, I'll go back, I'm going to hit hide element. And now I can place my other point, and I'll do it in the same manner. I'll just place it off into space, and I'll turn on my reference planes and then use my align tool. And there's my, hey, there are identical points in the same place, and say whatever. I'm going to go ahead and click on that, and I'm going to give this a name, and this will be my curve said type 1 and type 2. That should have been curve type 2. Obviously, you can only have unique names. Now that I have that placed there, I can click on Home and Component, and because I've programmed all of my curves, all I have to do is pick my type 2 curve, again, place on work plane, and I need to pick it, and then make sure both of my crosshairs highlight. And so I should have both of my type 1 and type 2 curves as they occur in relationship to my analog model from that 0, 0, 0 point. At this point I can go back and just reset my temporary hide so I reveal both points. And you notice when I hover over the points now, because I named them, when I hit tab, you'll see at the very bottom it says curve type 2. When I hit tab again, it says curve type 1. That gives me the ability to then select the different curves.
And so you would put a point there for every curve. So say you have 10 different curves, you put 10 different points right there.
Yeah, so that we're always referencing that 0, 0, 0. And the reason from this curve is that just gives you the alignment. You know, everything will always be aligned to the same spot. Then we can play with, you know, the position of this point later on, and then whether it's up and down, twisted, or whatever. Once I have these section curves, you know, I can just hit Create Form and hit Solid Form, and then I've got my lofted shape. Some of you might have a shape that looks orange. Anyone have an orange shape? Okay, I saw that. Anyone else? You have to make sure that when you do Create Form, you use the solid form and not the void form. If it's a void form, it'll turn out this orange color, which means when you actually bring it into any kind of environment, it won't appear because it's a void. It's invisible. If you happen to have an orange form or you've accidentally selected it, whenever you select your surface, you have these properties down at the bottom, identity data, that says solid or void, and it's set to solid. I can just click on this and change it. So if you accidentally have the wrong thing, you don't have to redo your shape, just change that property. Okay, so once I've done that, I'm going to go ahead and set up just a couple of parameters associated with these placement points. And again, I want everything to grow in the same direction. And so I'm going to move this one point, which happens to be my curve type 2. And I can set up another set of parameters in this file that just talks about the, let's see, curve 2. I'll just say curve 2x, curve 2y, curve 2z. Name's not important. And you notice I use the underscore a lot instead of using the hyphen. Remember that I like to occasionally, you know, space out my numbers and all of that kind of thing. One thing is if you happen to have a parameter, let's say I have a space between curve and the number, later on when you start to use this in a formula, it's going to get Revit's going to get confused and think that the curve is the name of the parameter and that 2 is some sort of you know, number mathematical expression to be used. So a lot of times I'll either not put any spaces, or if I want a space, I use the underscore. So your shift hyphen. So anyway, I'm going to set these up real quick. Z. And then I can, oh, and since we're also doing a rotation, I'm going to also set up a rotation angle for this placement point. Make sure your type parameter is set to angle. And because I'm doing that, if I'm going to start to rotate my point and these axes around, I want to make sure that when I snap my dimension, I'm not snapping to a plane, but I'm snapping to the point. So I'm only highlighting that point. So you could always turn off those planes if you want, or just go ahead and make sure you're snapping to that point. And I can change this to be my X, my Y, and then my offset is my Z. And then while I'm there, I might as well set my rotation angle. So now I can test this out a little bit. Let me just rotate it a little bit, like 10 degrees. And you can kind of see that the bottom of my curve kind of kicked out a little bit. If I do a little more extreme. So because I'm just rotating that origin point and its placement, you know, obviously my shape's going to be moving as well. I'll just keep that one there for now, and then I'll take this other one. And at first it's going to try to relate the way that reference planes and reference points work in Revit is they want to reference something. They're just that, you know, they're set up to always be in reference to one another. So at the very start, you notice when I start to move this point, this other point is moving in direct relationship to it. That's just a default setting, but once I set this other point to have its own parameters, then that will kind of go away, and it's all, it'll be based on all the parameters that you've set up. So don't be too alarmed if you notice all of a sudden this starts moving around. But what I'm going to do is the same thing for this point. I need to set up these other parameters. I wish there was a quicker way to set up parameters, but unfortunately, this is the way it operates. You could be.
Do you set up, like, do you do this kind of work in practice for like create families for like a curtain wall or something like that?
Yeah. So in practice, like working in the office, like, you know, every little component that you bring into your work environment in your project is a family that has a set of parameters to it. You'll find a lot of people, if you go to like revitcity.com, which is a forum where people upload a bunch of models and you can download them and insert them into Revit. There's a lot of bad models in there. You have to be real careful because there's a lot of people that don't set up anything with parameters. So you get these like one-off objects that if you really want a really big file, start putting in, if you have, let's say, a door or any kind of element that's going to, you know, change size quite frequently, try putting it in one at a time because someone didn't set it up with parameters, and that's basically putting in that object one at a time into your file and just adding to it. Whereas you could just have one, you know, little, you know, 300 kilobyte, 300 kilobyte, you know, file that's actually, you know, making 100 different things in your project. So in Revit, you want everything, you know, everything's going to have some set of parameters to it, and if it doesn't, then you have a hard time scheduling it. You know, eventually you need to schedule all of your different parts, and then you can't easily manipulate it and customize it for, you know, something else that you want to use. So yeah, you're doing parameters every day, and this is, if you ever take like Autodesk University, or not Autodesk University, but if you go to some training place where they teach Revit, they get to family types and parameters at the very last segment, and they go, oh, by the way, you can do all this stuff. But this is like the main thing that drives everything in Revit. So if you understand parameters and start to understand, you know, how this starts to work, then pretty much you can customize and do anything. And that's one of the big critiques, especially in academia, is that a lot of the professors don't like Revit because people don't know how to customize it. And people are using all these objects that you're like, okay, well, why don't you make that what your design style would be instead of what someone else built.
Yeah.
So, you know, ideally, you know, kind of what we're doing here when I'm setting up all of these parameters, I don't know what type of scripting experience or anything like that that people have, but if you were actually doing this in RhinoScript, or, you know, in order to make anything in Rhino parametric, you have to have Grasshopper plugin, or you use script with VBScript and RhinoScript. I would have to program all of these parameters one at a time as well. And with Grasshopper, you're doing the same thing, but you're just kind of placing these little plugs. Those are basically the same thing that we're doing here. We're just actually, we don't have a visual reference, it's just a type reference. So anyway, I've set up all of those. That should be curve 1 angle. And let me set up this other point, and then I'm going to get into.
Your curve 1 angle is still length.
Oh, is it length?
Yep.
Yep, that's not good. And what's frustrating is once you set up a parameter, you can't change the type of parameter it is. You think you could do that, so I got to delete this. I'm going to copy and paste. Say copy, Control C. I'll remove this, and then when I add my parameter, I can just Control V the name and make sure this is an angle. Also, another thing that might help is that Revit has a built-in calculator, so that if for some reason you don't want to have to figure out with your own calculator, okay, I measure this as 2 inches, and obviously I can do the math in my head that that's 32 feet. But let's say I have 4.75 inches. I could type in equal sign 4.75 and then say times where's my times 16. And it gives me my 76 feet instead of trying to come up with, do all this calculation and then type it in. You're kind of doing it twice. You might as well just do it right here in the formula in the box. So just make sure it's in the value when you do the equal sign. Otherwise, the formula wants you to do all these other things. So anyway, I'm going to take that back to whatever it was, 20 feet. And I set those up. Okay, everything's good. So now I come back here. Let me take this to my Y. Take this to my rotation, and my offset. You notice that when I go into the offset, my angle parameters weren't available. When I was in my angle selection, none of these other parameters were available. That's how it knows what you're going to be selecting. So I could take all this back to 0. There we go. So that's what I would do for all of your curves in your model, is if you can do it all with one curve, you'll save yourself, I think, a lot of time. Instead of having to make all these individual curves, you can just, you're just figuring out what you're typing in for each of those values. And then later on, we can change those values. What I want to go over today is what is the difference between a type family or a type parameter and an instance parameter. You'll notice that when I'm in my curve, and you might want to load up your curve that you've made just as a reference, is that when I'm in the Home tab and Family Types and I add a parameter, one of your options down here is a type and another one is an instance. Then under instance, there's another thing called reporting parameter. We're not going to get into reporting parameters right now, but I'm going to tell you what all of these different parts are. A parameter type is always associated with a family type. So a family type is when you've entered in all your parameters and you've hard-coded whatever the values are, and you click on family type and you hit new, and you've named it, that's one family type. That means that these parameters, because they're type parameters, are always going to be associated with a type, and a type is based on a pull-down selection of, basically from a pull-down selection menu. So you know that when you bring this in, you've seen so far that you basically select, I want type 1 or type 2 or type 3 or whatever you've named them. An instance parameter is a one-off set of parameters that are associated with the curve. For every time you place that curve, it has its own instance of parameters that have to be entered. What that means is you can have some of these things that are customizable on the other file or within the other file instead of having to come back here and keep changing the values and then re-importing it every single time. But there's some there's some positives and some negatives to working in both of these ways, and I'll just kind of showcase what you can do. The other thing is that if it's an instance parameter, you get this other option to select reporting. This will come in handy a little bit later, but you can essentially have some parameters or some dimensions that just report information, just what it's saying, reporting parameter. So you could have it set up a parameter to report the length or the width of something. And if you've set up other instance parameters that could use it in a formula, you could basically have, let's say, a family type come into a project environment, and maybe that family type changes. Maybe it's adaptive, and we're going to get into adaptive stuff. You might not know what the actual width is going to be of that object once it's placed, because it's going to adapt to something. But you can have it report that information, and then you can have another parameter do some calculation with it. So that's basically the reason for reporting parameters. And obviously we will get to that, but it's a little more advanced concept for now. What I'm going to do is just take some of my existing, so I'm just going to do, let's say, point 1, my x1 and y1 and z1, and I'm just going to hit modify, and I'm going to change this to an instance. Whenever I change it to an instance, you'll see in parentheses the word default is associated with it. That means that every time you bring in this family type, the default value will always be this 40 feet, for instance, that I have typed in here. I'm going to do the same thing with my y1. I'm going to change that to an instance. And then my z1. I'll hit OK. And I'm going to rename this file just so I have a different set of files. And I'll call this one has instance. This way when I load it into my other project, I still retain my other curves just to show you the example. So if I click on the curves that I've already placed in this other file, look off to the left, I have only these set of parameters available, and I have my pull down menu where I can select different different types. If I want to edit this parameter, I can come into edit and then sit here and associate it with, I can actually do the change here instead of loading it into another or opening it back up. But basically you're changing it only within this file, and that's fine, you can do that. But if I change this to my instance family, my type 1, it's still the same curve, but now look off to the left. Because this was an instance that was placed, I have these parameters in here that I could actually change on an instance. If I were to place this curve one more time, I'll say create similar, I'm just going to place it off to the side. Looks really different. So I've got all these values over here. If I change this value, my whatever point, let's change this to like 50 feet. There you go. You see how this curve changed? But this one didn't. Even though they're the same type, that's because they have their own instance items that are customizable within this family. If I had this as if I change this back to my type that doesn't have the instance available, I see it's just really far up. the same curve, if I were to go into the edit type and then manipulate these values, all of the times I've placed type 1 curve will update.
It's like component and groups in SketchUp, I think.
Right, yeah, just like a group, just like in SketchUp you got components, groups, just like in AutoCAD blocks and Rhino blocks. You know, if you make a block of something, if you edit that block and you've placed that block 100 times, all 100 pieces are going to edit or change as well. The other thing, let's say I have this instance parameter, you can then, once it's brought into another family, you know, I could come in here and since this is a family type that's associated with surfaces, I could set up a couple extra values that I could change that would be associated with these original values that are instance parameters. I'm just going to just do a couple quick ones real quick. X, simple Y, and Z. I could, with this instance param or this instance, use this little button to make it equal to something that's going to be only customizable to a type of surface. I'll kind of explain what that means in a moment. So I'm changing all these to...
You put that one on Z instead of X.
Did I do that?
Mhm.
It's been a long day. X. No, it should be Y. No, it should be Z. Okay. So it changed dramatically because whatever that point was, point 1, basically in this default setting, it's all set to 0, 0, 0. That's why it went back to whatever. But if I'm setting up new surface types within here, I could, you know, have those same points equal to something else. Like that. Maybe that was too extreme. So anyway, I can set those values here now because I've made them an instance and then made them equal to parameters over here. This is kind of a way of importing parameters from one family type to another, because instead of having to work with, let's say you were working with 7 different family files, you'd have to keep opening each one up and editing them, or using the edit command, you know, edit type over here. So just another trick, you can later on always change which one is an instance and which one isn't. You might decide later on in your design process that you always want point number 5 for some reason to be customizable in another setting, and that's why you would start to use an instance. Everyone kind of understand that? Understand the concept? I'm not saying you have to use it, but it's just another tool for what you can do in this setting.
If you were to bring in that instance curve again and have it in the file twice, would you be able to edit the instances individually? Like, would they each be standalone, or if you edit one, would it change the other?
So if I bring in, let me place another reference point and so let me bring in another component, and I want my instance version, type 1. So I guess what you're asking is if I don't associate with these buttons, this particular instance, and I change these parameters, only this one curve is going to change. But if I went back and I actually associate these to the same, I'm doing it again, the Z, and then the Y and X. Now if I'm in here in this environment, it's going to change both of them because they're all equal to the same that same parameter.
Okay.
So if you wanted them to be different, you would just keep doing the edits over here, and then you can sort of customize it that way. Another example of what we can do with all of our different parameters, excuse me, you notice off into the side you also have, we've been working with the value column. You can also start to think about your project in a computational manner where things have some relationship to one another through a formula. That's basically computational design, is you have a set of points or objects that have some relationship to a parameter that is changing and has a mathematical equation associated with it that also then changes the rest of the form. The way that this works is, let's say I, for some reason, always want, whenever I change my Y9 component, I always want my Z to be, let's say, 25 feet away from it at all times. All we have to do is, in the formula section, you notice there's already equal sign, so we don't have to type in equals again. We can just type in the exact name of the parameter, and then your mathematical equation, I'm going to say, will be 25 feet. So you saw that number change to 113 feet. I can lock them together, or keep them unlocked. At the moment, I don't think it makes a difference. So then basically anytime I type in a new value for Y9, and click off into space, my Y10 is always updating. So in some regards, I mean, if you really wanted to, you could figure out some mathematical equation that creates your curve. And you could have it where you only have to change the x1 value, and your 2 through 10 automatically update to something. So it might not be something as you'll do initially, because you want your initial form to look like your model. But when we get into ways of manipulating our model and our different types, you might start to think about the equations, and it uses the same mathematical methods as it, you use your parentheses, your divisions, however far you want to go. You can add in as many different parameters as you want. You just have to make sure that your parameter is named exactly, and it's case sensitive, exactly what you have already set it up to be. So that parameter already has to exist. And then it is automatically going to try to reference something, and if it doesn't exist, it's going to tell you and give you this actual error. That's also why, if I change Y9 to be, get rid of this formula. Let's say I named my parameter Y-9, and I come in here and I'm going to say I want Y-9 plus 25 feet. It doesn't know what that is because it looks like a mathematical equation, and there's spaces in there, and I think even if you took out the spaces, it would still give you that error because it I say y minus 9 plus whatever 3, you still get it because it's still looking for the Y parameter, and it doesn't understand that the rest of it was supposed to be part of a name. So whenever you're using numbers within a parameter, or just whatever, I like to use that underscore, to separate it.
What if you make that,
Or you can just take out the space and call it like 1 and that should be fine.
what if your value becomes associated with a formula and you make it an instance, how does that affect that?
Yeah, so the way that the formulas work is only instance parameters can reference instance parameters, and only type parameters can reference type parameters. So if you're using a formula, so for instance, my x1 is an instance parameter, and my x2 is a type. It should yell at me when I exit out of this. It'll exactly tell you that. It says my instance parameter can't be used for type formulas. And the reason for that is, your instance parameters are one-off customizable, and the type one isn't.
That's what I was wondering.
Yeah, so they can't kind of cross over one another. So if you get this error, that's why.
That's pretty cool.
Let's see.
Yeah, exactly.
The other, I'm kind of going over just parameters in general, just to show you some different options. Another one that I don't know if it would come in handy at the moment, but there is a yes/no parameter. I'm going to call this show curve for now. And if I do type parameter and call this yes/no, you get this checkbox. What this is basically a visibility option. So I could have a family that happens to have, let's say this happens to have a couple of other surfaces associated with it in this particular type. If I click on this element, you'll see you always have a visible parameter, and there you get the button. I can have this reference the show curve yes/no parameter, and then in my type, I can either make it checked or unchecked. So I'll call this one, I'll just do type 1 has it, type 2, and then do type 2, and then uncheck it, hit apply. You notice it doesn't do anything here, it goes away, or it doesn't go away, it's still there. That's because that parameter will only work once you brought it into your other environment. So let's say I have a new conceptual mass. Where was that? This guy. And I load this into. Did you see how I had that selection box that also popped up? If you have multiple families open and you start to load things in, it's going to ask you which file you exactly want to bring it into. And so I had a type 1, and if I do type 2, you see that that curve goes away. So again, later on, that might be another option. You might have additional geometry and forms that might be associated with one particular type that you could actually turn on and off just based on, once you brought it into the next environment. That's really all I'm going to go over today because I think that's a lot to take in. Really what you need to do is start to play around with these parameters and just kind of what I've gone over in class. I'm going to post another tutorial that will be what I went over in class today. It'll probably come out over the weekend. Let me tell you what's going to happen next week. Next Tuesday, I'm going to go over how we can do the rest of our model, because so far we've been dealing with the complex form, the funky foam part. I'm going to go over some quick methods, which are going to be very similar to what we've already done for your walking paths. Some of you have towers, so we'll go over what if you have different platforms. One thing that when we complete this model, remember this is like going to be an underlay that we're going to be applying other things to it. if you have stairs or ramps or anything like that for circulation of your path, we're not gonna model those right now because there's, in the project environment, there's a stair tool that will do that for you. We're basically concerned with making the surfaces that we're eventually gonna apply floors, walls, and curtain wall components to. So anything that is a stair or ramp, just keep that out of your geometry at the moment. So if you have a tower, you will just have some horizontal floating planes kind of situated around, floating in space. For Tuesday, I would like you to, based on the methods that we've gone over in class, set up your one curve to do, I would try to do all of your edges that you can and have that set up in one file and upload that on Tuesday. Just so that you can then place it by the 000 origin and you can loft your surfaces together and you should be able to do the same thing that we just did in class and have your complex form and everything lay out exactly in space. I'm not too concerned if you have weird little kinks here and there in your surface. Just get it in there, get it inputted, because we can always work out the kinks obviously with either mathematical formulas or just tweaking your numbers a little bit. Next Thursday, I'm not going to be here. I'm going to be on a plane to Colorado. I've got a project, basically a grand opening ceremony to attend to on a Friday. So I'm flying up there Thursday night, and I'll be back on Saturday. So obviously I won't be here for class. So what we're going to do is I'm going to go over how we can do the rest of this project, and then from Tuesday to next Tuesday, you need to complete your whole entire underlay of your analog model so that we have a starting point to then begin to do our other design. After I get back, we're going to get into working with curtain panels and starting to apply adaptive geometry to these different surfaces. This is one of these things where, let's say in Grasshopper, those of you that were able to take Grasshopper under my course, at the very end we did those very elaborate scripts that allowed you to take one little component and apply it to a surface and repeat it everywhere. And then you can change the parameters of that component, and then your surface would update. And it took like 4 weeks to do all that. We can pretty much do that in a class setting with working with some of the tools that are in Revit. And essentially what we're doing is we're going to be looking at ways of making this into a structure, because I don't care about this being a solid form. It's going to be more of a solid or a tectonic structure that might have some voids and structure like pipe columns and things like that that are associated with it that can be changed in an adaptive manner. And we're going to go over methods of doing that, and then working with another element called adaptive components. We'll get into all that after I get back. But what we're going to need is your base geometry in there, so that while we're working in class, we have something to apply it to and actually experiment with the different ways of utilizing the adaptive components. Okay? I'll stay after for questions. Make sure you're uploading all of your files. Today was just kind of an experimental one, so if it didn't work out or whatever, you still just upload it. And then, of course, next Tuesday, upload your curve as well. Yes?
Okay, so if I'm going to make this wave line with 10 points, and then I'm going to sit there and like make all these curves, like on stuff like this, like 10 points seems excessive for that. Because
well, I think it's going to be different for everybody. So like your worst case kind of condition may